IP SLA or IP Service Level Agreements are a feature built into Cisco's iOS that provides a way to monitor network performance. This is an active method for monitoring and reporting, as it has the ability to report on our traffic in real time. Metrics that IP SLA has the ability to report on include basic connectivity, delay, jitter, packet loss and sequencing, response time, and much more. This is a very common tool for service providers that they use to monitor customer sites, whether that's internet service providers or data center providers. But it can also be helpful to us as we're troubleshooting our own topologies. The main benefit of IP SLA is that it does not require a physical probe in order to monitor network performance. It simply uses generated traffic to measure the performance of a network between devices. Configuring IP SLA requires an IP SLA source and optionally an IP SLA responder. The IP SLA source will generate packets and send those to a destination device somewhere else on the network. This can be as simple as an ICMP echo used to continuously test reachability of a remote device. The response from the remote device would have timestamp information that would allow the IP SLA source to make calculations around certain network metrics that would be of interest to us. Optionally, a remote Cisco router could be configured as an IP SLA responder. This would allow the device to respond to more advanced IP SLA request packets. Some IP SLA operations will work without a responder on the other side. Some of those operations would include ICMP or HTTP. In order for IP SLA to be effective, they leverage SNMP traps triggered by events such as connection loss, jitter, latency, and packet loss, just to name a few things. For any IP SLA metric, certain thresholds can be set. So, for example, we might set a threshold for a specific round time trip metric. Anytime our IP SLA detected a threshold violation, that is, if the round trip time went above our configured upper limit in this example, an SNMP trap would be sent out to trigger an alert to an administrator. Also, threshold violations can be used to trigger other IP SLA operations for subsequent testing in the event of a violation. So, for example, the frequency of the probe may be increased to ensure that the information is accurate and that it's not just an anomaly. An additional and optional piece of an IP SLA configuration is some type of SNMP agent. That's going to give you the ability to more easily read and interpret ICLA reporting. Some of those popular options include SolarWinds, PRTG, and NIGOS Core, but there are many SNMP monitoring tools on the market. These are going to provide a very intuitive reporting method from a central location, similar to things we've looked at in other network management videos. In our next video, we're going to take a look at how to configure basic IP SLA to monitor network connectivity using ICMP echo messages.